Okay. Now that we have all this, we're going to go ahead and have our first example. And all this space that we have here in the green area, we're going to go ahead and write our first example there. Ready? Not yet? Okay, I'll let you guys write this down. For today, let me go ahead and clear. We're going to go ahead and write our example right here in the blue, green area. And it's right here. You don't need to copy the entire word problem. We can go ahead and copy our beautiful triangle and our figure that they create by Iron Man and Thanos. So I hope you guys remember. You guys remember what movie was it? Endgame, yes, sorry. Endgame. Goodness gracious, I forgot already. It's been since last year that I watched that movie. So this one says, use the trigonometric ratio, sine, cosine, or tangent to calculate the distance between Iron Man and Thanos. So here's Iron Man, here's Thanos. So yes, we have the distance here, and that distance is unknown. We don't know what that distance is. So we're gonna go ahead and write our question mark, and we're gonna go ahead and assign it as X. But more information is given. Iron Man is flying 55 feet above our ground, and his angle of elevation from where Thanos is standing is 26 degrees. Let me go ahead and define angle of elevation. Now, whenever you are standing somewhere, your angle of elevation basically is going to be considered a piece of reference. It can be either where you're standing, it can be where your eyesight is at, it can be either where your shoulder is at. You decide where your angle of elevation is located, right? So in this case, I decided, or we decided, or it's given that the angle of elevation for this example is where Thanos is standing right here. So this angle right here measures 26 degrees. So this is going to be our beautiful data. So we have this measurement that we need to solve for. We're given the height from the floor to where Iron Man is flying, and it's 55 feet. How can we find the distance from Iron Man to Thanos? Let's assume that this is perpendicular to the floor. How can we find that measurement? How can we find that distance? Well, in this case, which one? Sine. So sine would be opposite over hypotenuse. So here's our theta, here's our angle. We have opposite over our beautiful hypotenuse. So it is correct. So therefore we have sine of 26 degrees. And how do I write my beautiful ratio? Opposite over hypotenuse, that is correct. 55 over beautiful X. All right. Now that we have our ratio, now that we have the sine of 26 degrees, we can go ahead and use our beautiful table. And what does my table say that sine of 26 degrees is equal to? What is it equal to? 0.4384 equals 55. X. From here, we can go ahead and cross multiply and then divide. So therefore, we get X equals, we're going to go ahead and write our answer to the nearest whole number. So in this case, what is 55 divided by 0.4384? CJ. So 125.45? Does it give you 45 or 5? 45. So we round to the nearest whole number. So therefore, we're going to go ahead and take this in consideration. Round it to the nearest whole number. So it's X equals 1.25 feet. Woo-hoo! Not too bad, huh? So let's say that Iron Man already has all this technology integrated into his suit, right? Automatically, he knows whenever he aims at Thanos and shoots it with his suit, he knows how far of a distance or how far of a shot it's going to be. Now, in order for a programmer to know how far that distance is going to be, they have to apply the sine ratio here in this case, so they can find whatever height he has from the floor and up, he can go ahead and measure the angle of elevation, and then it will give him that distance away from that particular target that he's trying to hit. Okay, so this is Iron Man and Thanos. Ready for the next one? Woo-hoo, let's go. You go ahead and save. Okay, let me go ahead and clear. Everybody has this? Clear. Let's do the next application problem. Not this one. Next one, we're gonna go ahead and title cosine theta. We're gonna go ahead and write cosine theta. And this time cosine represents my, what ratio? My count? Adjacent over beautiful hypotenuse. Okay, adjacent over beautiful hypotenuse. Yes, in the green. Mm-hmm. So whenever you open the next tab, you should be able to see green and yellow. Correct? Yeah, open it. Open your cosine. Open it. So once you open it, you should be able to see green on top and then yellow at the bottom. It looks yellow and green, huh? I have neon paper, neon color paper, so that's the best I can get at home. All right. Ready for the example? All right, let me go ahead and clear from this page. And here's my beautiful example. Go ahead and copy this one down. Use the trigonometric ratios of sine, cosine, or tangent to calculate the length of Spider-Man's web if he wanted to aim at the highest point of the building. So he's down here and he wants to shoot his web so that he can go ahead and swing from the chandelier and start singing. If he wants, I'm not gonna sing that song, but I'll play it right now. So he's right here on the floor. He shoots his web at the highest point of the building, and he wants to know how far or how long is his web is going to be, right?
Uses geometry
and the yes, he does. He uses. So we're gonna. I hope he uses Euclidean geometry. I know he does, but I'll go ahead and. There's different types of geometry. Did you guys know that? All right. So from here, we're gonna go ahead and ask ourselves. He's not standing. Yeah. Spider-Man is standing 156 feet away from the building. So let's go ahead and say from the center of the building. And his angle of elevation from where he's at, so the floor, to where the highest point of the building is 33 degrees. We're gonna go ahead and solve completely and show our work from around to the nearest end. All right, you guys okay? Okay, so making sure, guys, that you're drawing your beautiful Spider-Man on your, you guys are drawing Spider-Man, right? And Thanos and Iron Man and everybody else? Okay, making sure. I'm gonna go ahead and check when I do a notebook check on Friday. Okay. So make sure you guys are drawing everything. It's an application example, the building and everything. That's why I'm giving you guys time. All right, I'm gonna go ahead and make these. Which ratio are we using? What type of sides? Which ratios? Sine, cosine, or tangent? Cosine. So cosine of what's our degree? 33 degrees. And our ratio is going to be 156 over beautiful X. Go ahead and solve for X. Let's see what you guys get. Degrees should give me what? What's cosine of 33 degrees? CP. 87 equals 156 over X. Therefore, I need to multiply X times 100, times 0.8387 and make it equal to 156. Therefore, my ratio now equals 156 divided by 0.8387. And the value of X equals, what is the distance between, or the length of Spider-Man's web from where he's standing all the way to the top of the building? 186 beautiful feet. Raise your hand if you got that. Woo, let's go. So 186 feet. That's correct. Ready for the last one? Yes, no, maybe so. All right, let me go ahead and save. Let me go ahead and clear. Everybody done drawing? Okay. So this time we're gonna go ahead and write our beautiful title, tangent theta. And this time we have TOA. So therefore we have tangent of theta equals opposite over adjacent. So let me go ahead and write adjacent. So we have opposite over adjacent in this case. We're gonna go ahead and write our problem here, or example here. We have enough space. Okay. Ready. Awesome. Okay, let me go ahead and clear really quickly. And go on to our next example. So this one, imagine that we are asked to find the height of one of the trees out here. Just any random tree that we have here on campus. Once we select that tree is going to be obviously having a shadow. Whenever the shadow is being casted or the shadow is made by the sun that it hits it over here on the left side of the tree, it's going to have a length of 23.5 feet. The angle of elevation of that beautiful tree from the floor all the way to the highest point on the tree is 46 degrees. We have to find the height of our beautiful tree. So I know my question says, given the height of the tree, it's backwards. Given the length of the shadow, we have to find the height of the tree. So let me go ahead and fix that really quickly. We have to calculate the length height of the tree, given the length of the shadow. Okay. All right. So the angle of elevation here is 46 degrees. Our beautiful length of the tree. Remember, what if we were outside? We're going to go ahead and grab our measuring tape and measure how long that distance is from the shadow, from the middle of our beautiful tree. And we're going to go ahead and find out how height. Now, the reason why we would do this in this case, or in any case, or why engineers actually do this in real life, is because obviously whenever buildings are very, very high, or in this case, trees are very, very high, it's not safe for us to be out there. We just don't have the machinery to get out there, whatever the case it is. Now, we can go ahead and be down here. We can go ahead and grab our survey machine that would help us find the elevation of it. And from that side, or from that point of elevation, we can go ahead and determine the degree and then determine the distance from that object. So in this case, which ratio are we using? Tangent. So it's tangent of 47 degrees equals, how do I write my beautiful ratio? It's opposite over adjacent, x over 23.5. So let's go ahead and solve. What is tangent of 46 degrees? (1.0724) equals x over 23.5. We're going to go ahead and cross multiply, and we get x equals, what is x equal to? (25.2), and it says round to the nearest 10th, so we keep it at 25.2 feet. So what's the height of my beautiful tree? 25.2 feet. Not too bad, huh? All right. Let me go ahead and pause.